All right, I'm going to do a few circle questions with you, and the first one is an example of a circle, and we have two tangents here that are coming from a common external point, and they are both touching the circle in one spot. Now, what we have learned is that two tangents that are coming from the same external point, such as this, they are actually congruent to each other. They are the same length. So we're trying to solve for x in these equations. What we're going to do is take each one of these expressions, one of them being the first tangent expression, which is 2 plus 9x. The other is negative 2 plus 11x, and we're going to set them equal to each other because these segments should be congruent. They should be equal in length. So now we're going to solve this equation for x. So we want to get x's on one side of this line, numbers on the other side of this line. Doesn't matter which way you do it, we just got to get it done. I usually would take this number to this side if it is a smaller number, and it will prevent me from having a negative x, but it does not matter. So on the left, we're left with 2 equals negative 2 plus a 2x when we combine our 11 and negative 9x. All right, so we have x isolated. Let's take this negative 2 to the left side of the equal sign. So to undo that from the right, we have to add it. And now we're looking at 4 is equal to 2x. We're trying to get x by itself, so we will divide both sides by 2, and our answer is 2. So to solve for x when you're dealing with two tangents coming from an external point and it's the same external point, then you set those expressions equal to each other and solve it for x. All right, so here's a different scenario. And this one is where you have a radius of the circle, which is your 9.3 length, and it is intersecting a tangent to the circle. Now, what happens when the radius meets the tangent is there is a right angle formed. That's just one of those things about circles that's always true. What we're trying to find is the length of this question mark, which is actually the hypotenuse of this triangle. So this is one of those a squared plus b squared equals c squared questions. This is Pythagorean theorem. So we will use that to find the length of this blue, well, this side of the triangle indicated by this blue arrow here. So it doesn't matter really which one you use for A or which one you use for B, but it does matter where C is. So let's plug these in. This is a review question. All right, we need a calculator for these lengths. So 12.4 squared is 153.76. We will add that to 9.3 squared, which is 86.49. It's still equal to c squared. So let's add these two numbers together on the left. We're looking at 240.25. Now that, remember, that's still equal to c squared. So how can we undo c squared just to get c? Square root it. So the square root of 240.25 is about 15.5. So that is the length of our missing side there. So again, that was just an extension of Pythagorean theorem. We'll try one more of those with a little bit of a different variation. This one is similar, but we are not actually looking at exactly the same thing. All right, so we've got a segment here. Your tangent is 8. It is still intersecting this radius. Actually, now it's a diameter of 7.5. So we still have a right triangle here, but this time we're just told this little piece right here is 7.5. So remember, what is the distance from the center to the circle? That's your radius, right? So that means that the distance from this point, same point, the center, to this point should also be 7.5. If we're going to do Pythagorean theorem, we need to know the length of this entire piece of the circle. So your diameter is 15. So let's let 8 be A, B 15. I'm still trying to find C. We're still looking for the Pythagorean theorem on this one to find the hypotenuse. So your a squared would be 8 squared, b squared, 15 squared. That's set equal to c squared. So this would be 64 to 25. When you add those together, you'll get 289. And then the square root of 289 is 17, and that's actually exact. It's a nice little Pythagorean triple there on that triangle. So in summary, when you're trying to find the length of one side of a triangle that is made up of a tangent and a radius and another segment, we use Pythagorean theorem. And then when you're trying to solve for the value of x when you're dealing with two tangents, all we need to use is those two expressions set equal to each other and solve for